Okay, in this video we're going to try and make sense of this scary looking formula down here, which we may or may not use in class, I'm just not sure. But we're going to make sense of it in this video either way. So what we're going to need are three things, but really two things. The center of dilation, and for the purposes of this video, we're going to let this point right here be the center of dilation. We're going to choose one of the vertices. In the previous video, we talked about using the origin, and then we did a point up here. Now we're going to use one of these vertices, and that is the point 3, 3. That is our center of dilation. And we could use our projection lines to create a dilation, but we want to do it by a specific scale factor. So we're going to use, let's say, a scale factor of 2. So let's get clear about what this formula means right here. The A and the B are the center of dilation. So I'm going to rewrite that. My center of dilation is 3, 3. So A is 3 plus K is my scale factor. So this K right down here is the scale factor, and I said scale factor 2. So we're going to do 3 plus 2, then open parentheses. X minus A, I'm going to leave that X alone for the moment, and A was the center of dilation. And then for the Y coordinate, we have something similar. Our center of dilation for the Y coordinate is B, so that's 3 plus, and then our scale factor, K, is 2, and then Y minus B, so open parentheses, I'm going to leave that Y alone and put in minus B, which is 3 yet again. So this is intimidating, I know, but we're going to get through it. Close out the big parentheses. So what you've got here is this chunk on the left is transforming your X coordinate, and then this other chunk on the right of this comma here is transforming your Y coordinate. So let's say we wanted to know, where does this point end up after a scale factor of 2? Well, that point looks to be located at 1, 2, 3, 4, 5, and up 7. So that is the point 5, 7. So we're going to use this formula, center of dilation plus scale factor times, now this time I'm going to substitute in the X coordinate. We started with 5, 7. We want to know what happens to that point when we dilate about the point 3, 3 by a scale factor of 2. So I'm going to plug in the 5, the point I want to know about, minus 3, and then again using this 3 here plus the scale factor of 2 that I've decided on, and then the Y coordinate this time was 7, so 7 minus 3. And close parentheses, and then we can simplify that real easy with PEMDAS. 5 minus 2 is 2, times 2 is 4, plus 3 is 7. 7 minus 3 is 4, times 2 is 8, plus 3 is 11. So our new point after a scale factor of 3 dilated around the point 3, 3, or this vertice here, 3, 3, is going to be at 7, 11. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to be right up here. And we could do something similar for this point here. If this point is 7, 3, then we would plug in 7 for this X and 3 for this Y and simplify down and find a new point. And notice that this point and this point, let's do it real quick. 7 minus 3 is 4. 4 times 2 is 8, plus 3 is 11. So this is going to be over at 11, 2, 3, 8, 9, 10, 11. So I think it's going to be right there. And what I want you to notice here in the final seconds of this video is that these 2 points line up exactly with the projection lines that we would create for any dilation. And then you can just kind of connect the dots there. So getting familiar and comfortable with that formula, if we use it, is probably going to take some time, but maybe I'll do another example right after this.